So going around is a sheet that I need you to fill out with your name, lab section, email address. There is a bunch of things that I'll show you as we go along that I'm going to send to you tonight, and you need those things for doing your project and putting things together. So make sure you fill out the sheet that is being passed around, all right? I'm going to start with going through the syllabus, and then if you have with you the syllabus and then the cherry colored pink packet, which is kind of basically all the guidelines for the project. I'll start with going through some high points with that, and then we'll go through some of the other things you got, and I'll show you some examples of things that you're going to be working on, okay? So at the top of the first page of the syllabus is all the lab sections that are doing projects. So you need to be enrolled in one of these. Tuesday AM, Thursday AM, or Thursday afternoon with Thursday PM with Dr. Johnson. So is everybody now enrolled in a section? Okay. If not, see me immediately afterwards, because we have to make sure that paperwork is finalized this week. Dates that we're going to go through are in this paragraph, but also I'm just going to go through the schedule. There's some really important dates in here that you need for the project. So the first one, last week we did the library training that we had after the data discussion last week. So we've already completed that one. This week you guys are going to be working in lab on your project proposal. So you want to come to lab just like you normally would at the regular times, because that's when you're going to be working on getting all your pieces together, and that's when your lab prof is most conveniently located in lab as well to help you get all your pieces together. Two big important dates. For the Tuesday lab, the 13th, so a week from tomorrow, that is when your proposal is due. So your proposal and all the pieces that I'm going to talk about are due a week from tomorrow. The Thursday labs, they are due on Thursday, so a week and a half, the Thursday before spring break. So we take all of spring break, and it really does take like the full week and a day to get everything together for projects. So that's why you absolutely have to have all your proposal pieces turned in before you leave for spring break. As soon as I meet with all my students on Thursday morning as they hand in their projects, I'm going to be starting to put the pieces together for projects. So it starts that quickly, things are starting to happen. So it's really important, if you're going to do a project, you absolutely have to meet these deadlines. Otherwise you will not be able to do a project, because we won't have what we need from you, all right? The final last one that's an important date, so in between there, we've got spring break. We're getting, well, you submit your independent project proposal, then we've got spring break that we're getting ready, and then basically from the week after spring break, the 5 weeks of classes after spring break, then you'll be working on your project. Your final report is due then Friday the 27th. So that's another important date that is on there, all right? And the way the points will be broken down for the projects is your proposal that you turn in and all its pieces are worth 50 points. Then the independent project, your in-lab work, how you handle the project in lab and outside of lab, and then the final report that you submit and your notebook is worth 150 points. And then the project safety and technique is worth 50 points. So the whole second half of the semester, there's 250 points possible available, okay? As far as lab safety, all the lab safety rules that have applied in Chem 255, 256A still all apply, and probably even more so with projects than they have previously. As far as lab rules, make sure that you are following the rules we've had all along. Especially important with cell phones, you really cannot use anything in your ear, so no phones, no earbuds, anything in your ear while you're working in the lab during independent projects, because you really need to be able to hear everything that's going on around you. As far as your notebook, the same guidelines that we have used all along for your notebook will still apply, and we'll give you some more specifics. Dr. Johnson and I will give you some more specifics with that. If you have a situation that applies under ADA guidelines, you need to register with the Academic Success Center, and then please contact your instructor to discuss that. And then as far as academic integrity, make sure all the work you do is your own work. And then at the end, you get to evaluate the course. So, are there any questions with the syllabus or the dates? That's the big thing, is making sure that you are aware of those dates that are on there, all right? And all the handouts that I gave you, I'll post on the Chem 256-11B Moodle site, so that's now open. The video from today, and then all these handouts that you got last week will be posted on there, okay? All right, so next one is to look at the pink sheet, and I'm going to kind of give you the highlights of each of the pieces of the pink sheet, okay? A little bit large here. So, first of all, important, be here at lab lectures, so you're all here at lab lectures, so good job. The independent project, there's a couple guidelines that are really important to what type of project that you do. So you need to make sure it's an organic chemistry lab, so it has to be related to organic chemistry, first of all. You're going to have a target compound that you are trying to synthesize, okay? And you need to have your instructor's approval of this target. So once you have identified your target, you want to make sure your instructor says, okay, you are good to go with that target compound. What you are proposing is a 3-step synthesis to make that target compound. And sometimes that could maybe be more than 3 steps, depending on the situation. Like maybe a couple of them are pretty easy, or maybe 2 of the steps are going to happen one right after the other, and there's not really going to be an isolation in between. So there's sometimes special circumstances for the 3 steps, but use kind of the 3-step rule as what you are looking for. And we want to have one of those be a carbon-carbon bond forming reaction. Oops, sorry. The reason for that is we want there to be a little bit of challenge in the reactions that you're doing. So we don't want something like you deprotect, do something, and then protect the same site, or you basify something and then do something and then acidify it, and that's your 3 steps. So we don't want it so trivial that you could do your 3 steps in a week or something like that. We want a little bit of element of difficulty there. So that's where this carbon-carbon bond forming reaction requirement comes from. Now sometimes people, depending on the project, may not have a carbon-carbon bond forming reaction, but something else that they're doing is of similar difficulty, and so that can be the case as well. But these are kind of like the basic guidelines, okay? The other thing is you're going to plan on, but you need to talk to the person whom this target compound is originating from. You usually are going to start with about 5 grams of your initial starting material, okay? Because we want to make sure that you have enough as you go through your steps that at the end you have something that you're isolating, all right? Now, so I've kind of covered the first paragraph, and we covered the second paragraph in talking about the due dates. So the due dates again are there for Tuesday, March 13th for a Tuesday lab section, Thursday, March 15th for a Thursday lab section. I'll give you a little bit more specifics on that here in a little bit. So then, with these 3 steps, you want to make sure that after each step, you're getting full characterization. Of the products that you're making. So you can kind of think of experiment 20 as a little bit of the model of what you want to be doing with your synthesis. That was developed to kind of be the bridge experiment between experiment 256A and 256B, okay? So each of those steps, before you went on to the new step, you would fully characterize the product that you made, and you would analyze the data and make sure that the data looked okay for you to continue on to the next step, all right? So you're going to need to do the same thing with your synthesis. After you have completed a step, you want to make sure that you get full characterization of that product. So get an IR, an NMR. Probably a new requirement to that will be that you also get GC mass spec. So you have mass spec data depending on what the compound is, if it'll be okay in the mass spec. If it's a solid, you're potentially going to be collecting a melting point too. But you want full characterization so you know, can you go on? Did you make the same? Did you make what needed to be made? Is it pure enough to be carried on? Is there something else that needs to happen before you go on to the next step? So there's all sorts of questions that need to be answered once you have made a product. So that's why the full characterization is important. And so then going down to number 4, and I've kind of, 5 was the characterization part. I'm going to bring in now 4. You're going to have the same pieces in your notebook that you had for experiment 20. So you'll have a Prelab for each step. You need that signed off before you start that step. And after the first week, when all of you get started at the same time, people are going to end up in different phases of their project depending on what is going on. If someone needs to, do more purification versus someone who can continue on to the next step, or maybe the first step doesn't work, so now we're going to do something else or do the first step again. So after that first week, pretty much everybody's going to end up in a different spot, depending on where your project takes you, okay? So with the pre-labs, make sure you have us sign off on it. We won't always be going around and checking for pre-labs just because after that first week, everybody's going to be in a different spot, okay? But make sure you get it signed off, and then you'll have your experimental just like you did all along, and then you will have a mini conclusion for each step. And this needs to be written before you get ready for the next step, okay? And even if the first step you attempt doesn't work, you still need to put the mini conclusion in there that, okay, it looks like you've got starting material back. What is your next step going to be? So even if it's kind of, we're redoing things, you'll still need that mini conclusion in there. So you always want that in there before you get ready to start the second step or the third step, all right? And within that mini conclusion, you'll discuss the characterization that you had. Then number 6 is just talking about at the end, you're going to write a final summary and conclusion of your data and of all your characterization and your synthesis. So when we get closer to that, we will give you more information about that. But just know that at the end, there'll be a final report, basically, that you are submitting, and that's when you will submit your notebook as well. So here's where it talks about you will start with about 5 grams of your starting material, and that can, you know, depending on what you're doing, that can sometimes, you may start with less and sometimes you may start with more depending on what you are doing and what is, what potential yields you're expecting, things like that. So some of this you may not know right now, but as you get your literature for your synthesis, then things may be figured out as you go along. Here's a list of compounds that we need to stay away from due to the hazards that are involved, and your green sheet will go through some other things that we'll kind of try and stay away from as far as organic lab is concerned. And so this one is due to potential carcinogens. We also have just reaction conditions that we have to be careful of. So like just based on the equipment, we can't do anything greater than 60 psi for pressure. And then there's some other things that we won't be able to use, all right? I've pretty much gone through the grading. You've got your proposal 50 points, your summary and conclusion and notebook, and the project is 150 points, and then safety and technique is 50 points. Is there any questions on that? Okay. And then here's the due date again, the 27th, Friday the 27th. Okay. And when you hand in your notebook and your report, the other thing that you will be handing in is any samples that pertain to your project that we should be collecting. So depending on who you're doing your project for, any of your final compounds, most likely, especially for research, are going to want to be submitted because they'll want to hang on to those final compounds, or even potentially what you have left of your intermediates, okay? So kind of new to what you've done previously, basically you'll be handing in the notebook and the paperwork, but also those final compounds, and we'll help you get those prepared towards the, at the end of the semester. We'll help you get things into vials and things like that. Again, academic honesty, make sure that your work is all your own work and not someone else's. All right. So the proposal, each of these 3 synthetic steps, you need to have primary literature that is going to be your basis for those steps. So you need literature that tells you basically how are you going to do the chemistry that you want to do. And that from that literature, what you're trying to get is the experimental details of what you are trying to do. So up until now, you've had everything out of your lab manual. There may be some things that you still use out of your lab manual, but not everybody is going to be doing anything that's related to what is in the lab manual. So you have to find the literature that tells you how to perform the steps. So each step needs to have a piece of primary literature that backs up that step. And so in lab this week, that's what we're going to be helping you, first of all, collect. Is once you have gotten your target approved, then the next step is to find the literature to put your synthesis together. How are you going to synthesize your compound? So all of the information that you got last week from the library, as far as the resources that are available in the library, as well as how to use SciFinder, and what journals are accessible and so forth, that all comes into play now when you're trying to find your primary literature, okay? And in the end, when you put everything together, you're going to reference everything as using the ACS style guide, and putting your proposal together for your citations. The other thing you're going to do is when you hand in your proposal, you're also going to hand in all the literature that goes with your synthetic steps. Okay, so we'll want a copy of those journal articles. And not only are you going to turn in 1 copy, you will actually turn in 2 full copies of your proposal. One is the one that we will grade and we will give back to you right after spring break. The other one we hang on to so we know what you are doing in lab each week, and we have your literature to remind us what your steps are, so we can be staying on top of what you will be doing each week. So just make sure, remember, when you go to hand things in, you need 2 full copies of the proposal and all the literature that goes with it. All right. The next part is kind of what we covered in lab last week of the different handbooks and so forth that can be used for this proposal. And then there's also a list here of potential journals that could be used for this project, but this is not a full all-encompassing list. This is, kind of the short list, considering it was, I think it was 904 chemistry journals. Like, we have access to like over 900 journals. So by no means is these 10 going to necessarily take care of all the possibilities of where you could be looking for information. One thing you do want to be thinking about, though, when you are using SciFinder, besides is what you find to be references potentially for your synthesis, are they available to you? Also consider what language they are available to you in. So if you're finding all journal articles that are in like Russian or German or something like that, it may or may not be something that works out if we can't get it translated for you to be able to understand what the experimental details are and what the journal article is telling you. So just kind of be aware of that when you are searching for information as well. That make sure that you will be able to interpret what they are telling you. So the next part is kind of the pieces of the proposal. So I'm going to show you that over here. So I've got an example proposal to show you the pieces, and then the next page kind of just gives you a checklist of make sure that you have all your pieces together when you go to hand things in. Okay, so you're going to have all your literature together for your 3 synthetic steps and the literature that is your literature precedent for that. And then you will have the proposal that you prepare. And so that proposal should have name, the usual things you would have, turning something in, name, section number, date on it. And then you should also give kind of like an intro paragraph that introduces the project. What is the project going to be used for? What is the significance of the project? So kind of like your intro that you would write previously, but you're writing it as a proposal. So it's a future, third person, future tense paragraph, because all of this you're proposing to happen. So it has not happened yet. So then for each of your steps, you should give a description, and now this is not, experimental specifics. This is just a general description of the step, but include things that would be important to know. So are you going to need to do this at -78? So you're going to use a dry ice acetone bath to hold it at a really cool temperature. Or is it going to need to be heated really hot? Or is it just going to be stirred at room temperature and then maybe cooled down or heated? So give the pertinent experimental details and conditions that are important to that step. And then what you're going to do is you will use Chemdraw. So one of the things that I am going to send you in that email is a link to Chemdraw, and you can use that link to set up Chemdraw on your own computer. You'll have free access to Chemdraw because of the license that we have paid for, all right? If you choose not to put Chemdraw onto your computer, Chemdraw is also available in the computer labs where Topspin is available, but it may be easier to actually put it onto your computer. All of the reactions and structures you will want to draw with Chemdraw, and then we can show you this week how do you draw something in Chemdraw and then you copy and paste it into a Word document, all right? So you'll show the chemistry of what is going to be happening in that step, and then you're going to give your literature precedence for that step, whether it's just a single precedent or maybe you have multiple precedents. Sometimes that's the case as well. And then like in this case, they used benzene as the solvent in the literature precedent. This case, they were attempting the step first with toluene instead of using benzene, because benzene is one of the solvents we shouldn't be using in the organic lab. All right. And then here is the full literature citation in using ACS style, so using the ACS style guide. And remember, in the library last week, they showed you if you go to the ACS basically database website, at the top there, you can click on the tab that will get you to the style guide. So you have access to the style guide online, all right? And so you will go through this for each of your steps, showing a description, showing then the chemistry that's involved, and then giving the literature precedent. So sometimes what you are following is exactly the same. Sometimes, and that's what, go to the last page here. Sometimes you have a literature precedent, like say you wanted to carry out this reaction, but the literature precedent you had was for this reaction. So in that case, what you want to show is make sure that you are showing the reaction that is going to be carried out, and then you show the reaction that is showed in the literature precedent if it isn't the same identical reaction, okay? Now, just be careful when you're doing this. Make sure you're in conversation with your lab prof to make sure that you are similar enough in what you are proposing to the literature precedent, if it isn't exactly what you want to do, all right? And so you will go through this for each of your 3 steps. And with this example, there wasn't like that where there were completely different reactions. There was just potentially different conditions, or like in this case, we've got 2 references that could be used for this reaction, or we're going to use kind of a combination of what was shown there. All right. The next thing that you will have to do, so kind of going back to our list here, is then this is number 5. Then you need to put together a data table of all the chemicals you will use. You will also want to, it's a good idea to give the CAS numbers so that it's very clear what that chemical is. And then all the physical data that you would have prepared normally when you were preparing your pre-lab, okay? So you want to make sure you give melting point, or sorry, molecular weight, melting point, boiling point, density, amount used, and how many moles you're going to be using, okay? In this table, you want to list every chemical that you are using, and then you also want to list every product that you can find information for, or at least list the product, and then you can, if you don't have any information, you could at least calculate the molecular weight for it, all right? But you want to make sure that you're very complete with this table. So in this case, the table was put together in landscape, which a lot of times is probably a better option to get it all to fit together instead of trying to turn it the other way. The other piece that you need is the hazards and the toxicological properties of the chemicals that you are using. And so when we did the library session, I told my section's a really good place to get that information is the Aldrich catalog, or sigmaaldrich.com has a lot of useful information on there. And so kind of a guiding principle that I use for putting this together is when you're trying to think about, because you could like this could be all consuming all the information that they're going to give you about each chemical. Think about what your normal organic lab practice is, okay? So you're going to, everything's going to be done in the hoods. You're going to wear your safety glasses. You're going to be dressed appropriately. If you need gloves, you're going to wear gloves when you handle the chemicals. Those are your normal safety practices. So what you want to list here is the above and beyond the normal safety practices, okay? Now, other things to consider, you know, if something's extremely flammable, then list that. If something's very moisture sensitive, then list that. Or something's very air sensitive, things like that. But when part of what the information that they're going to give you is how to handle the chemical, and so think of listing things that are above and beyond what you normally would do in lab, all right? So you don't have to list, okay, you know, using a fume hood, wear eye protection, that kind of thing, all right? So this is one table that you have to put together is your physical data and hazard table. It could be one table, or if you feel like it's better to do the physical data on one table and then do the hazards and toxicological information on a second table, that's fine. Just make sure that you are complete for all the chemicals you're using and producing. The next thing is you're going to prepare a chemical order form. I'm going to show you what it looks like blank. And then what it looks like put together here. So one of the things that I'm going to send you in that email is a blank chemical order form, okay? And what you need to put on this order form is any chemical that you need for your project that isn't already found in the organic lab and easily accessible to you, okay? So that purple sheet, that purple half sheet that I gave you, so this guy, the reason that we gave you this is so you know what is going to be readily available for you in lab. So these are you do not need to include these on your chemical order form unless you're using, you know, large quantities of them, okay? So, you know, if you're using, you know, of the solvents, we'll have all the red can solvents available. We'll have the red cans full of the solvents. You know, say you need to use like a couple 100 milliliters of like diethyl ether or something like that. That's okay, you know, that's not going to be crazy. But if you need like liters or a liter, you may want to put that on your chemical order form because that's just kind of a large amount of it. So I need to make sure that we have, in amongst everyone else using it, I have, you know, plenty on hand for you, all right? But usual kind of normal size scale of things that you've been doing previously, we're going to have those chemicals available for you, okay? And so the red can solvents are listed on here. We have a solvent, an area for dry solvents, and we'll talk about dry solvents here in a little bit, but we have access to 7 solvents that are dry, moisture-free, air-free. So these will be available. And then we have the acids and bases that are available, and then just make sure you pay attention to not only which ones are available, but what form they're in. So like HCl, we have 1 molar and concentrated. So say you need 6 molar HCl, you don't need to list it on the chemical order form because you're going to take concentrated HCl and dilute it to make it 6 molar HCl, okay? So just pay attention to what is available here. As far as drying agents, we'll have magnesium sulfate, which you've been using, but we'll also have sodium sulfate because sometimes, depending on the chemistry of what you're doing, sometimes some things are not compatible with magnesium sulfate, and it's better to use sodium sulfate. We'll also have silica gel available for you to do column chromatography. So unless you're doing like a ginormous column, we'll have enough of this available for you, okay? So just keep this the purple sheet in mind when you are preparing the chemical order form, because you don't need to list the things that are on that purple sheet unless you're using a really large quantity of it, all right? And so on the purple sheet, you're going to give the chemical name of what you need. Now, what you need to be careful of is make sure you put things like numbers behind the name. So this was 2,2-dimethoxypropane. When we list it in the order form, we want to put those numbers behind the name because this needs to be alphabetized. So if we leave all the numbers in there, it kind of ends up messing that part up, all right? So things like 2,2' usually will move the para to behind it. So just be kind of conscious of things like that. And if you have questions, let me know or let your lab prof know and we'll figure it out. But basically, what we end up doing with this list is I start with a blank list and I end up putting everybody's order form into it, and then we alphabetize the whole thing and then go start looking for all the chemicals that you need and then narrow down what we've got versus what we're going to have to order, all right? So anything you can do to help this part out would be really appreciated. Then you're going to list the CAS number of your chemical. This is important because if we have any question at all about what you are using, if you've got the CAS number of what you want, we will easily be able to make sure that what we found is the same thing as what you want. Any chemical that's listed for purchase will have its CAS number there, okay? Then you want to list how much you need, all right? And you want to make sure that you give a realistic amount here. Now, it doesn't need to necessarily be taken, like this case, 4.385 milliliters. Like, you could list 4.5 milliliters, maybe 5 milliliters, that's fine. But make sure you've listed the amount that you need, because sometimes we'll be ordering a 25 milliliter bottle for you and you only needed 5 and you're the only one that's going to use it, so you're going to have plenty and everything is good. But sometimes multiple people need to use the same amount, and so, or the same thing, and so we're going to tally up, all of the N-butyllithium that needs to be used and order, the appropriate amount for everybody to use from the same bottle or multiple bottles, all right? So make sure this is accurate. And then amount on hand and location. Another piece that I'm going to send to you is how to access our inventory and then go into the inventory and figure out what chemicals are on hand and what chemicals are available, okay? And so you go to this website. The login is chemordering@hope.edu and the password as hope. And so then you will, here, let me make it so then you go through and enter the information for the chemical you're looking for, and then you're going to go through and there's going to be possibilities, okay? So you will select on those possibilities, and then it will, when you click on the possibilities, it will tell you where things are available, okay? Now, sometimes, a lot of times you won't necessarily know how much, but you can give the location of where things are available, okay? Something that is important for that then is what are the room numbers you can look in, okay? So 3109, 3121, and 3129 are all associated with organic lab, Okay, so here's our 2 labs, here's the organic stockroom. Any of these 3 are fair game. So if you find chemicals that are listed here, list that as a possibility, all right? Otherwise, the chemistry research labs, and particularly the lab or labs of the person that you're doing the chemistry for, okay? So basically, the second floor, the first floor and second floor research labs are, or sorry, second floor, third floor research labs are possibility. Specifically, you know, if you're doing a project for Dr. Sanford, well, look for where it's going to be listed for Dr. Sanford, okay? Or Dr. Johnson and so forth. Then another place to look then is the lower stockroom, so 1033, all right? So organic numbers, 3109, 3121, 3129, chemistry research labs in particular, who you're doing your work for, and then 1033, all right? Now a lot of times we don't know how much we have, but just go ahead and list the location of where we're supposed to be able to find it, all right? Then this quantity to order comes into play between what is on hand and what still needs to be ordered. And sometimes you may just have this whole thing filled out because you don't know necessarily what's on hand, all right? So if you don't know what's on hand, just put here what you need to order, all right? Then if you're ordering, then you want to put the information of where we're going to order from. And so primarily we want to use Sigma Aldrich for that, all right, because we get the best discount. That's where the most amount of chemicals are going to be available. But if what you need is not available, or you look at it, so I would look at the chemical, then I would go down and look at the pricing, and then select, you know, look at what thing that you want to be purchased. Make sure that it doesn't say, you know, like back ordered till May or something like that, because that's not going to work for your project, all right? So it may initially look like they have it, but go through all the clicks to make sure that, see when it is available. If it's not available for a long time, we're going to have to go for something else. Or if Aldrich just doesn't have it, period, we'll have to go for something else. So what I listed on the other side are potential other chemical suppliers that you could use besides Sigma Aldrich, all right? Then the last thing here as far as the chemical is the catalog number for that supplier. And make sure you're very careful picking the one that you truly need, okay? So, like N-butyllithium. N-butyllithium comes in multiple solvents and concentrations. Make sure that you have found the one that you need for your procedure, and that catalog number corresponds to what you need, all right? So be really careful here. So it's really important that you fill this information out carefully, because we're going to be taking it from when you've submitted it, and then put it together in our long list and find the chemicals and order chemicals, and all this is happening over spring break when you're not necessarily available to tell us what you need or what you don't need, okay? So with that, over spring break, if we have a question, we'll probably email you if we can't, between myself and Dr. Johnson, figure it out. So make sure you're checking your email over spring break too, in case we have a question for you, all right? Then you'll want to give your name, because we need to be able to associate you with the chemicals that you need, and then your prof's name, and then lastly, give the step that the chemical is needed for. So of your 3-step synthesis, is it needed on the first step, second step, third step? This is important because sometimes something, you know, a chemical may not be available till the second week of projects. Well, if you don't need it till your third step, maybe that's okay that we can still order it and it comes in a week later than everything else. Or maybe you need something that's kind of expensive for your last step. Maybe we're going to wait and not order it right away because it is so expensive, and see how the project's going, and then order it when we know that we actually are going to get there or not, okay? So it is important that you fill out that last piece of information, all right? Okay, so beyond sending you the order form, sending you these instructions, sending you the link for getting Chemdraw on your computer, the other thing that I'm going to send you is this template for a PowerPoint slide, okay? And so what you should do, use this same template, because we're going to put a poster together of all the projects that are being done, and we put this outside of the organic labs, and people like to come and look and see what, like, they're used to us doing this, so they'll want to see the poster, and they'll want to see all the projects that you guys are doing for independent projects. So take this slide and put your information in there, okay? But keep using this same template, because we want the poster to look nice too, okay? So if everyone picks their own template, it may or may not look so great, all right? So you're stuck with what I've picked, so sorry about that. But put in your information, so you'll put in your name, you know what lab section you're in, what is your final target compound, or sometimes people end up with multiple target compounds, that's okay too. So put in, you'll take from Chemdraw, draw your structure very carefully, make sure it's real, you know, this is posted for the general public, and especially chemistry profs like to look at this, okay? So make yourself look good, do a really good job with the Chemdraw, make it look the way it's supposed to. Also include, we don't make it mandatory that you include a picture, but we do like if you would include a picture, because then we associate the person with what they made. And like right now, you could look at last year's poster is posted outside of my office. All right, so you can see what last year's looked like, and then give a little bit of a description of what is going to be involved in the project. Okay, and again here, make sure it's got, you know, the right nomenclature. You know, if you've got cis and trans isomers or something like that, make sure you're italicized. Make sure you use all the right formalities that you need to use for organic chemistry. All right, but in addition to the order form that you have to send to me, so besides turning in your proposal, with all the pieces of the proposal, your literature precedents, a copy of your order form, a copy of the PowerPoint slide, you're going to send to me the order form and the PowerPoint slide, so that I can put the order form in the list of chemicals we need and put the PowerPoint slide in the poster. The other reason that we use the PowerPoint slide is we will mark your spot in lab. Okay, so we will put you in lab such that every person has their own space for the duration of the project. So you won't have to, you know, like someone comes into work and they have to move out of the way of someone else because they're using that space. So you won't get your own hood, but you will get your own half of the hood that you get to work on, and that is your space for the duration of the project. So we'll have you put that up there at the top when you start your synthesis to mark where everybody is working, all right? So with, actually, let me make sure I've shown you all the pieces, I believe so. Oh, actually, sorry, I've got one more thing I need to show you. And then I'm gonna give you some more specifics on the due dates. So the green sheet, I had not shown you that yet, okay? On one side of the green sheet gives you some information about chemicals, and this is by no means a complete list of chemicals we need to use, anhydrous conditions, and some description of how we will handle that, and chemicals that we need to use inert conditions, so we can't have oxygen in those conditions. So here is a list of examples of chemicals that will need to be used for, and most likely if you see these chemicals in the literature, this is definitely, like, you definitely will need to handle these in inert conditions or anhydrous conditions. And so we will show you how to do this in lab too. We won't just, set you free and you just figure it out on your own. We will give you guidance on how to do this, but we want to make sure that you are aware of the chemicals that potentially would need these and what type of conditions would be involved. The other side, so keep this in mind as you're looking through your precedents to do any of the chemicals you're using fall in these categories. Other chemicals that you will need professor assistance when you are handling, so we will not let you just handle these all on your own. We're going to help you when you need to use these, so you will need to make sure that you have scheduled with your lab prof using these chemicals, and when you and your prof are available to set up the reaction that would use X, Y, or Z chemical. Then there's also the list of things that we just can't use because it's organic chemistry lab, and some things are just a little too toxic and so forth to be using in an academic lab. All right. So keep the green sheet in mind as you are preparing things and looking at potential literature precedents. Then a couple other things for you. First of all, a lot of times with your projects, it's not all necessarily going to happen nice and compactly in your 5-hour lab section because we're now using literature precedents that are possible from all sorts of places. So there are also open lab times that are available. So on Monday, after spring break, the labs will be available from 9:30 a.m. to 4:30 p.m. So we won't have another lab lecture. So we'll give you that extra hour that you potentially could then work in lab. Now with open lab, because everybody's doing things different, and like I can't keep track of all 27, 28 of you and what your projects are, especially those that aren't my students. You need to be in contact with your lab prof if you're coming in to open lab, okay? So you can't just freely come in. You've got to talk to your lab prof about when that is happening and make sure they're available for you. On Wednesday, it's 9:30 a.m. to 3:30 p.m. and same thing on Friday. Okay, the order form that you have to get back to me, so your chemical order form, and your PowerPoint slide, here is when they are due. So for Tuesday a.m., I have to have this by March 13th, so next Tuesday, 12:30 p.m. And this is my lab section, so I'll give you more instructions for that this week, okay? Thursday a.m., again, my lab section. Yours is due on March 15th, so that's Thursday, 12:30 p.m., okay? And again, I will give you instructions. Here is Dr. Johnson's. Yours, because you are at the very end, and I am putting all this stuff together, and it's right before spring break. By 3 p.m. on Thursday, March 15th, you have to have handed things in and email me your chemical order form and your PowerPoint slide by that time. Okay, so these are the due dates of you emailing back to me your complete chemical order form, complete PowerPoint slide. All right, questions you guys have? Okay, just make sure before you leave that the email sheet that was going around, make sure everybody has their name and lab section on that email sheet, okay? So make sure, if you haven't filled it out, I think, does Sarah have it? Okay, Sarah has it right now, so if you are not on this sheet, make sure you are on it before you leave today, all right?